Hi everyone, welcome to Acharya Mathematics. It always seems impossible until you visit Acharya Mathematics. I hope you have seen my previous videos. In case you are not seen, please go through it.
Students, let us start fresh chapter trigonometric functions. Before going to commence the chapter, just we recall what we have studied in class 10. So in there we have studied that trigonometric ratios of an acute angle and trigonometric ratios of some particular angles, trigonometric ratios of complementary angles and fundamental identities. With keeping all these in mind, we commence the chapter. So here in this chapter, we shall generalize the concept of trigonometric ratios to trigonometric functions. It means that here we discuss for general angle, not for only acute angle. In 10th standard, we have discussed trigonometric ratios of an acute angle. Here we discuss for different angles. That is said to be the trigonometric functions. So here let us discuss one by one the concept. That is the first one concept is angle. Even though you have studied about angle in earlier classes, you would have been think what is necessary to discuss again angle here. Yes, it is. Let you know in later. So, what is the definition of angle? You have learnt in high school classes. Angle is a plane figure bounded by two lines meeting at a point. Is it right? Angle is a plane figure bounded by two lines meeting at a point. This is being called as angle. Is it right? Now here we discuss the angle in a different manner. So here what is a different manner means? Suppose I am going to take a line ray. Suppose that this is a ray. Okay, Naika. Suppose the ray is rotated for some extent. What happened here? Angle is generated. Is it right? So here, let us see here. I am going to take a ray. Let OA be a ray. Let OA be a ray. Suppose that the ray is rotated for some extent. What happened here? The angle is said to be generated. Is it right? So this is the definition we use here. Okay, now. So here, then what do you mean here? Angle is formed by rotation of a given ray at a fixed point. That is the definition here we did. That is the definition of angle. Okay. So here the initial ray, the original ray, we call as initial side of an angle. And the final position of the ray after rotation we call as terminal side of an angle, and fixed point O is called vertex. Is it right? Here what happened here? I am going to take here again a ray. OA is a ray. It is initial side. Suppose the ray is rotated for some extent, so angle is said to be generated. So I am going to take this as terminal side. Is it right? So what is the difference between these two means? Here the sense of rotation is different. Here the ray is rotated in this direction, means that is in anti-clockwise direction. Here the ray is rotated in this direction, this clockwise direction. So here in this case we say that angle is positive angle. we say that this is positive angle. And in this case, we say that it is negative angle. So it means that the angle depends on the sense of rotation. If the sense of rotation anti-clockwise, then we take it as a positive angle. If the sense of rotation is negative, sense of rotation is clockwise, then we take it as a negative angle. This is about the angle. Next, let us discuss measure of an angle. Roughly, we speak that the gap between initial side and terminal side of an angle is termed as measure of an angle. So we say that like this: the amount of rotation performed to get terminal side from initial side is called measure of an angle. Suppose I am having an initial rate is OA. Next, here this is I consider as OB is terminal side. This initial side, terminal side. The amount of rotation performed to get from initial side to terminal side is called measure of an angle. Okay. Next, let us consider a ray OA. Is a ray. O is a fixed point. O is a fixed point. Suppose that the ray is rotated in the anti-clockwise direction and it comes to the same position after one complete rotation. Here we say that one circular angle is generated. Here, angle of the circle is 360 degree. Okay, I hope you got it. Next, let us come to the units of measurement of angles. To measure the angles, we use always two types of units. That is, one is degree measure. Second one is radian measure. Or it is called as circular measure. We discuss one by one. The first one we take a degree measure. Already you have studied degree measure in high school class, isn't it? But here we go to in depth here. So here in degree measure, first I consider one complete rotation of a circle. That is, one complete rotation of a circle is said to be one revolution. So here I am going to take let OA be a ray. Suppose that the ray is rotated and come to the same position. What happens here? One circular angle is generated. That is 360 degree. Here, this 360 degree is divided into 360 equal parts. Like this, so on. Here each part is called 1 degree. Each part is called 1 degree. So it means that 1 by 360th. 1 by 360th revolution 1 by 368 revolution is equal to 1 degree. Next here again I am going to consider 1 degree. This is 1 degree. Okay. This is 1 degree. Here I am going to take as 1 degree. Let us just assume that this is 1 degree. Here further 1 degree is divided into 60 equal parts. Here each part is called 1 minute. Each part is called 1 minute. I mean that here 60 parts. We divide the 1 degree as 60 equal parts. Each part is called as 1 minute. So here 1 minute equals how much degree? 1 by 60th part. 1 minute is equal to 1 by 60th part of 1 by 60th degree is said to be 1 minute. Further I am going to consider 1 minute. So this is 1 minute. We write 1 minute like this. And again, just for the sake of understanding, I write this 1 minute like this. Here further 1 minute is divided into 60 equal parts. Here each part is said to be 1 second. It means that here 1 by 60th minute 1 by 60th minute is said to be 1 second. We write like this. Okay, so here what to observe here, 1 by 360th revolution is equal to 1 degree. Okay, next 1 minute is equal to 1 by 60th degree and 1 by 60th minute is equal to 1 second. Now here tabulate here, then you understand very easily. 1 revolution equals 360 degree. Is it right? Next, 1 degree is equal to 1 degree. 1 degree is equal to 60 minutes. Is it right? So around cross multiplying, what happens? 60 into 1 is 60. That is equal to 1 degree is equal to 60 minutes. Next again 1 minute is equal to what happens here? 60 into 1, 60 seconds. That is here 1 minute is equal to 60 seconds. Here 1 minute is equal to 60 seconds. So here we have to learn this. 1 revolution is equal to 360 degree. 1 degree is equal to 60 minutes. 1 minute is equal to 60 seconds. Note, here 4 right angles equals 360 degree. 2 right angles equals 180 degree. Let us see that we have a ray like this. Suppose if there is no rotation is found by a ray, then we say that this is 0 angle. This is 0 angle. Okay, there is no rotation. Okay, and next semicircular angle, but it is rotated in the clockwise direction. Therefore, we take it as minus 190 degree. Is it right? Next, I am going to have a straight line, and this is a straight line. It generates how much angle here? It depends upon the sense of rotation. If the line is rotated in the anti-clockwise direction, the angle is generated 270 degree. Next, suppose the line is, we have a ray like this, OA. It is rotated in the clockwise direction. So here we say that it is minus 90 degree. Okay. So these are the examples we use in the degree measure. In degree measure, we measure the angles in degrees, minutes and seconds. Let us we move to the next unit, that is radian measure. First, let us see how do we define radian. To define radian, we take a circle and we take it as a center of the circle as O. A radian is an angle subtends at the center of a circle by an arc length, and it is defined as ratio of length of an arc to its radius. So this is the definition of radian. I mean, suppose that here angle is like this. From the center I have taken like this. So it generates. So here we have like this. Suppose that the angle is generated by an arc length this much, arc length this much. Okay. Suppose here the arc length subtends an angle at the center. So this angle is measured by using the formula angle equals length of an arc divided by radius. So here that is we write it as theta equals length of an arc as L and radius is R radian. So this is the definition. So it means that here I am having the radius is R, and length of an arc is L. Then it is theta is given by L by R. So this is definition of radian measure. Next. So here L by R is radian. That is the formula you have to learn. Theta equals L by R. We sometimes write it as theta is equal to L by R in power C. Here C denotes radian. Okay. So this is the formula. Now let us see different cases when R and del are in different cases, what will happen? Let us see here. Next measurement is radial measure. Here we say that either radial measure or circular measure. In this type we measure an angle in terms of radian. Let us we know that what is meant by radian. How do we define radian? To define a radian we need a circle. Consider a circle whose center is O and radius is R. Here, radian is defined as the angle subtended by an arc of the circle. Do you understand here? Radian is an angle subtended at the center of a circle by an arc. You got it here? Radian is an angle subtended at the center of a circle by an arc. Here, this is angle subtended at the center by an arc, and it is defined as angle equals ratio of length of an arc upon radius. So this is definition of angle in this type. So here angle we denoted by theta, that is equal to length of an arc. We take it as length of an arc L. So radius already taken R. This is R. So this is theta. So theta is defined as arc length divided by radius of the circle. Here we use the unit as radian. L by R radian. Though this is the definition of angle in a radian measure. Okay, you got it. So now can you define now? Radian is an angle subtended at the center of a circle by an arc and is defined as ratio of length of an arc to its radius. So this is the definition of radian. Now let us check the different cases, remarks. I take it as first one. Let us see here theta equals L by R radian. Sometimes we write as small letter c as in power, that is we read it as L by R radian. Okay. So here I am going to take different cases. Different cases means what happens if length of an arc is equal to radius. Suppose if length of an arc is equal to R, then theta becomes, what happens here? L by R, we can cancel out L by R because L is equal to R, so we get 1 radian. So we write it like that, 1 power C R, we simply we write it as 1 radian. So radian is defined, 1 radian is an angle subtended at the center of a circle whose arc length is equal to radius. So this is the definition of 1 radian in general case. Okay, next let us we take again particular case. So particular case means I am going to fix the radius as 1. So here I am going to take remark number 2. I am going to take R equals 1 unit. So 1 unit means 1 centimeter, 1 inch or 1 meter, whatever it may be. Okay, got it here. Now I am going to observe what happens here in the case of a unit circle. In the case of unit circle, angle is equal to L divided by R is 1. So that is equal to R. So it center of a circle in a unit circle is equal to its arc length. Or got it or not? Suppose this is an angle. Suppose that here I am going to consider the radius as unit. Here angle subtended at the center is equal to the arc length. So this is the arc length. So here theta is equal to r. In the case of unit radius. Okay. Next again in this unit circle we take different cases. The case 1 here what we have to learn here in the case of unit radius. So suppose this is 1 and this is 1. Okay. Then this is L. Okay. So here theta is equal to L. Again we hear what happened here in the case of unit circle arc length is equal to angle. Okay. Next here we take again we discuss different cases in the unit circle. That is first one is see here. Suppose this is an angle. Is it right? Is an angle. Suppose here this is an arc. Suppose arc length increases. What happens here? Angle is also increases. Yes or no? So here angle is directly proportional to the arc length. Suppose that here what we observe that in the case of unit radius theta is equal to L. So if its arc length is 1, angle is 1. If arc length is 2, angle is 2. If arc length is 3, what happens? Angle is 3. Suppose arc length, what happens here? When the initial side of an angle and terminal side of an angle coincides after one rotation, what will be the angle? We have to calculate there, or we have to calculate the arc length. So here arc length is equal to arc length equals circumference of the circle is 2 pi r. We are discussing unit radius. That is 2 into pi into 1. That is equal to 2 pi. So it means that theta is equal to 2 pi. You got it here or not? When here, what happens here? This is the phi terminal side of an angle. If it overlaps after completion of one rotation, so here arc length is equal to circumference circle, that is equal to 2 pi. Therefore angle subtended. So therefore angle subtended at the center is equal to 2 pi. It means that suppose that here. So this is 2 pi radian. In the case of it is radius is 1. Okay. So this is O, this is A and B. Mean that OA and OB overlaps after one rotation. Okay. So here what we have got it here in case of unit radius, angle is equal to length of an arc. Suppose I am having a unit circle whose length is here arc, suppose arc length is 1, then here theta angle is 1 radian. Is it right? Angle is 1 radian if it is measured in the anti-clockwise direction. Again I am having a unit circle, center OA, this is A, this is B, okay. Here suppose the angle, this arc length is again 1 I am taking. So here angle, suppose the angle is measured in the clockwise direction. Here what happens? The angle is again 1 only, theta equals 1, but we are measured in clockwise direction. Therefore it is minus 1 radian. Okay, this is minus 1 radian. Next, suppose we have see here. Again I am going to consider a unit circle. So arc length is 1. So this angle is 1 radian. I take one arc length of 1. So again it is 1 radian. Is it right? So this is O, A, and now I am going to take this as B. So then what happens? Angle AOB is equal to terminal side. Suppose what happens? 1 radian plus 1 radian plus 1 radian. How much here? 3 radians, isn't it? If I measure this angle in the clockwise direction, this angle is said to be minus 3 radian, like this. Okay, okay, I hope you got it. Sorry, okay, I hope you got it. Next, let us see here relation between degree and radian measure. Degree and radian measure. Relation between degree and radian measure. Here you observe that in degree measure, one revolution equals 360 degree. In radian measure, we observe that one revolution gives 2 pi radians. So here both left hand sides are equal. Therefore, we say that 360 degree is equals 2 pi radians, or we say that 2 pi radians is equal to 360 degree. Okay, so this is the first relation. 2 pi is equal to 360 degree. Then dividing by 2, what we get here? Pi is equal to 360 by 2, we get 180 degree. Again by dividing by 2, how much we get here? Pi by 2 is equal to 90 degree. Suppose if we divide this one by 3, pi by 3 is equal to 180 by 3, that is equal to 60 degree. Again if we divide pi as by 4, we get pi by 4 is equal to 180 by 4 equals 45 degree. Suppose if we divide left hand side pi by 5, so here 180 by 5 gives 36 degree. Okay, suppose if you multiply by 3 by 2 to this one, so what happens here? That is 3 pi by 2 is equal to, I am going to multiply by 3 to this one. What happens here? 3 into pi by 2 is equal to 3 into 90 is equal to 270 degree. Is it right? These are the frequently occurring angles. You better to buy up all these results. Okay, this is the measurement of radian measure. Just we have discussed measurement of angle in degree measure, radian measure, and relation between degree and radian measure. Next, one more important here we use to solve the problems or convert the problems from degree to radian, radian to degree. That is, here we observe that pi radian is equal to 180 degree. Therefore, this is pi radian. Okay, pi radian is equal to 180 degree. Therefore, 1 radian is equal to 180 divided by pi degree. Okay. Suppose let x be an angle, multiplied by x on both sides, x into 1 becomes x into 1 radian, is it right? X into 1 radian is equal to x into 180 by degree. So x into 1 is, that is x is equal to, we get x radian is equal to x into 180 by pi degree. You have to by this one. Then you can solve the problems, or you can convert the given angle from radian to degree very easily. So next let us see conversion of angle from degree to radian. Here we know that 180 degree is equal to pi radian. Therefore 1 degree is equal to pi by 180 radian. Multiply by x on both sides, and what happens here? X into 1 degree, that is equal to x into pi by 180 radian. X into 1 degree is x degree equals x pi by 180 radian. Again, these two degree to radians. Okay, I am going to conclude this class. Okay, thank you.